Now we'll talk about child objects. This is one way to decompose the complexity of your application. So when you have a repetition of doing the same computations, or you have too much complexity in your current object, it's a good time to decompose by using child objects, where you can delegate some of the work to be done by the child. And here's the syntax. We have a define object with a name, in this case speeds of sound, no mix-ins for this example, computed slots just like you've seen before, and in this case we have a computed slot called the average speed, and that's going to take an average. It's going to divide the sum of 3 of these different speeds. So notice this is called reference chaining, where we have the cold speed, speed, and the warm speed, speed. Finally, the hot speed, speed. So the cold speed, the warm speed, and the hot speed are each a child object defined like this. We have objects, and then this is a list of expressions again. It's a list where each child object specification has its name, just like a computed slot name. But now instead of a normal expression, we simply give it a type, which is a literal symbol which names another object definition. And then we can pass inputs in like this, is with a parameter list, a list of keyword value pairs spliced after the type. So in this case, the only input we're passing in is the temperature into each one. But we have 3 different child objects here. Each one is of the same type. It's speed of sound at temperature, which we defined just in the last slide, and with a different temperature that we're passing in. So let's take a look at how this looks in code. So here we have the speeds of sound. And let's go ahead and increase the size. Control X, Control plus. Control X, Control plus again, to give you a good view of this. And here's the speeds of sound. We'll go ahead and compile this one. Control X, Control E on the last. See, it compiles real quick. And now let's make an instance and see how we can refer to these child objects. I'm going to do a make self. And this is in training G102 package. The examples file is listed in the training G102 package. So that means all the names for these definitions, like speeds of sound, by default will go into the training G102 package. So the way you refer to a symbol in a package, other than the current package, is with the package name, and then if you're just informally referring across packages, you can use a double colon, and then speeds of sound, like this. So the double colon is a red flag. You should not use that in normal applications. This means that speeds of sound is not exported. So it's not exported or supported as a symbol officially in the training G102 package. If it were, you could use a single colon. But right now we're just going to use a double colon because we're testing at the top level. So now I have a self, which is a speeds of sound, an instance of training G102 : speeds of sound. Let's ask for the average speed, and there it is, a certain number. But let's ask for the cold speed. See, that's one of the child objects. It's called the cold speed. And that returns us another object. See, it returns an object, an instance of speed of sound at temperature, because this child object is of type speed of sound at temperature. So you get back an instance of speed of sound at temperature. If I ask for the warm speed, that gives me a different instance of speed of sound at temperature. And I could ask for the speed from any of these guys. So the speed from that one is 9.85. For the cold one, the speed is 9.032. It's slower, so speed goes up with temperature. And then again, to take the average, I could copy-paste this expression. If I just want to test a certain expression, I can copy-paste it. As long as self is set correctly, the reference right here will know what object you're referring to, and that will resolve. And that always should resolve to exactly the same thing as the average speed, because we have that same expression here for the average speed up above. Indeed, we get the same result.